My name is Jason Lala. I am a certified practitioner at Next Step Bionics and Prosthetics here in Manchester, New Hampshire, as well as the clinical director.
My name is Arthur Graham. I'm the clinical manager in our Newton office on the outskirts of Boston, and I'm responsible for the day-to-day running of that office. We have the AquaCast Symphonie system in all three of our offices. We have one further office in Rhode Island, and we've been using that system now for almost 2 years.
So how long have you both been using the AquaCast system?
We've started with the passive system approximately 2 years ago, and then in the past year we had the upgraded vector control system, so it's been about a total of 2 years. And we do have our three offices here, one in Manchester, New Hampshire, as well as Newton, Massachusetts, and Warwick, Rhode Island, and we are fortunate enough to be equipped with that system in all three offices.
In regards to the SAS system, how many fittings have you done with this new system?
I would say we're now in the hundreds of successful fittings with the SAS system.
In regards to traditional socket designs, what are the differences you see between the two systems?
I think the big difference with this system is it has brought a level of consistency to the transtibial casting process that we really don't think was there prior to using this system.
And
I always felt, from when we were first introduced to this system, to me, we were designing a prosthesis in the socket itself as a weight-bearing object, if you will. The prosthesis is and traditionally, we have cast people in a seated position. So it made sense right from the get-go to be casting somebody under full weight bearing, which is the same environment and the same pressures they are going to be placing on the socket when they're walking. So that alone, to me, made a lot of sense and was significantly different than what we've done in the past. And again, the level of consistency that we can create due to the fact that we're using more science in the actual casting process than just pure hand skills. It certainly doesn't replace the knowledge we have as practitioners, but we had discussions about being able to test the outcome of various different liners, because we can create the same socket cast every time by using this Aqua Symphonie system, where in the past that was always relying on hand skills, which there would be differences every time you took a cast. So I think this technology, what it's going to allow us to do is really start looking at that socket technology and really start to determine what materials are superior, what type of liners are superior. And I think that's something that's been lacking in the past.
There have been attempts in the past by some companies to produce a form of weight-bearing socket. And also there's been attempts to produce a pressurized socket using air, for example. I don't think any of those have reached the level of success or consistency that we are currently having with the SAS system.
The profession itself, you hear there's a lot of R&D going into components. The major advancements that we see have to do with microprocessor knees and feet. There's a ton of money going into that, but at the end of the day, the technology that's bolted onto the bottom of the socket is only as good as the fitting itself. And I think it's something that that I personally welcome, is diving into that and putting more R&D into socket designs, interface materials, and looking at the outcomes and being able to determine, which one is superior. And this system allows for that.
In regards to those questions, has the SAS system changed the fitting process as well as patient feedback and especially timing?
Patient feedback generally has been very positive. The casting process takes a little longer in the setup and completion of the cast. However, that's offset by the savings in the fact that there is little to no modification of the mold after the process. And we spend a fair bit of time explaining the technique and the technology to the patients because it's obviously very different from what they've seen before. But generally speaking, patients are pretty engaged in what we're doing and trust their judgment.
Yeah, with the system, we're also able to, I think, project what sock ply they're going to be in, depending on how much pressure we want to introduce in the system itself. Whereas in the past, you may use a certain technique, you may wrap in a certain way, and 9 times out of 10, you may end up in, or 7 times out of 10, you might end up in a 1-ply sock fit. But then every once in a while, you would have that 3-ply fit or the 5-ply fit, which sometimes seems unexplainable. Again, with this system, using the app that is provided, we can consistently produce a 0-ply socket if we would like to. If you want to end up in a 3-ply sock fit, you have the ability to simply add the sock over the liner during the casting process. You follow the same guidelines using the app, and you'll end up in that 3-ply sock fit. So I will also echo what Arthur has said here about being able to save time on the modification side of things. Now, that doesn't eliminate our skills as practitioners. There is still going to be fine-tuning adjustments, and there's still going to be the alignment, which is crucial. But it has been so far very successful.
The first AquaCast system was a static system, and with this new SAS system, have you had to do any added construction changes to your office?
So once we had received the vector control system, it was pretty obvious that we would have to designate a specific area. You really need to run an airline to the system. We had tried portable compressors, but they really were noisy and not conducive to patient comfort. So we ran designated airlines, designated water lines to the system, and select a space in your facility that's designated as the casting area for the AquaCast Symphony.
Do you see any benefits in the new shape of the TT sockets compared to the hands-on techniques?
I think, again, the comment that I have received from most of the patients that I've fit with this, when we stand them, get them under full weight bearing, and ask them, one, how does it feel, and do you feel any pressure points? And the feedback I get is I don't feel any pressure points. It's a very consistent, even surface tension throughout my limb. And with the vector control system and the amount of compression that we're able to create during the casting system, it has minimized the need to add radical modifications in the socket in order to create vertical support. So it is a bit of a leap of faith initially. I mean, I think the reality is that if you're a successful practitioner, you found methods that have worked for you over the years, and to pry us out of that comfort zone and to try something else, I think is probably a bigger adjustment maybe for the prosthetist. But we were told early on that basically it was, trust me, follow the guidelines, and if these don't work out, then we can have discussions in the future and to see if there's necessary changes that need to be made. But honestly, it seems so far that it has turned out to be just that. If you do commit to it and follow those guidelines and do things properly, we're not seeing the need for some of the things we had to address in the past.
There's a famous saying that we've heard a few times as we've gone through this process, that physics will triumph art, and I think this applies solid principles of physics compared to maybe more of an artistic approach, which we're maybe doing with hand casting and hand modification. And again, it leads into, I think, just this consistency of result that we could achieve before, but we've just upped our success rate.
With the successful outcomes that you've noticed with the SAS system, do you think this new system will change the principles of the O&P business?
The O&P industry, certainly in the States, is sometimes a little slow to take up on new techniques and new processes. I think what you'll find is that companies like Next Step, who are, I think, leaders in their field, embrace this technology and adopt it fairly quickly. And I think there will be places across the country that will do it. There also will be places that look at it and see it as maybe too much effort or too different from the way they're doing things and not adopt it. But we know from our experience here that it's been a very worthwhile investment of our time and resources to get this technique down to the point where we're very comfortable with it.
Yeah, I mean, I feel as a company, Next Step Bionics and Prosthetics, we do have a good reputation, and we have been successful over the years. So it is a business decision. I mean, it is not. You do have to invest money. You do have to invest some time into this scenario. But we were finding, again, if we can create more consistency and keep or improve our outcomes, I think that's a worthwhile investment. I also look at it from another standpoint where this system, if I was a private O&P owner and had a practitioner that was relatively new, didn't maybe have a lot of hand skills, I mean, I can tell you confidently that you can use this system and with very minimal adjustments or modifications, someone who is maybe not as experienced is still going to get great results, and they're going to get that great result in a single check socket. Our business practice over the years has always been driven by outcome, meaning that we're not sacrificing the outcome to save money. And so we've gotten into those scenarios where the fit might be great and they're in a 5-ply sock fit. The patient doesn't want to be in a 5-ply sock fit. They want to be in a single or a 0-ply sock fit. So then you're doing additional check sockets. Again, with this system, if I know that about this particular patient, if I know that this patient doesn't want to wear socks, I can cast and know that coming from that cast to that check socket, I'm going to get the desired outcome for that patient.
To follow up on that answer, do you find that you're able to spend more time getting an optimal alignment for patients because of the better outcomes you're seeing with the socket?
Yeah, absolutely. I think, again, one of the things that we pride ourselves on here at Next Step is that all of our fabrication occurs in-house. So I have the ability to get somebody in, and within a 2.5-hour window, I can do a cast, a check socket fitting, and set them up and have them walking on that check socket here in our office. So it's because of the fact that I'm not spending as much time modifying, and it allows us to spend more time on the alignment, and really, that has been beneficial.
Do you find that you're getting more feedback from patients during casting now because they are fully weight bearing in the cast?
So we have used the system on existing clients. We have also fit patients who are new amputees. With the existing clients who maybe historically have been a 2 or 3 check socket experience, we're finding that we're often able to fit them with one test socket, and the feedback from them is often that this is the most comfortable fitting that they've had. With the new amputee, they obviously have less feedback, but it's still very positive in terms of how it feels when they actually weight bear. As Jason said earlier, I just think the concept of capturing the soft tissue and the skeletal structure under load, which is the first thing we do with the patient. We stand them up and we put them in a weight-bearing position in the test socket. We've already achieved that before we even set foot in the room with the test socket. So it's a huge advantage, I think, in terms of patient comfort.
Has there been any number one feedback from a patient that stands out for you using the SAS system?
I think from the first socket that we created here at Next Step, when we were visited by Andreas, we had a amputee who is in his mid-70s. He's been an amputee since I believe he was 9. So he has been in multiple different liners, multiple different type socket designs, multiple different suspension designs. And we fit him very successfully over many, many years. And to have him be fit in the Aqua casting system and stand up and walk on it, and he took notes, gave us feedback, and after a week's worth of time, he said, "This is the most comfortable socket that I've had to date." And that was, I think he was the first, so that was a little over 2 years ago. He hasn't changed sock ply, he's still in that same socket, and has been in for 0 adjustments. Like, we haven't touched that socket. So to me, that was an eye-opener right out of the gate.
With your success using the transtibial version, do you see a transfemoral version being beneficial to the O&P industry?
From what we've seen so far with the transfemoral design, I believe that's going to be an even bigger game changer than the transtibial design. I think the quality of transfemoral socket fittings is not particularly high across the country, and I think this has definitely the potential to improve the fit. And it's the same thing, you're producing a cast under load, and most casting that's done transfemoral wise is not produced under the patient's body weight. So I think using this technique will be a significant game changer, and we're very excited to start with that as soon as it's available.
Yeah, I believe, with both transfemoral amputations and through knee amputations over the years, especially we fit a lot of suction sockets here at Next Step, and I think any practitioner would agree that a transfemoral suction socket is probably one of the more difficult sockets to fit, just because you're dealing with capturing the skeletal anatomy in just the right way, as well as volume management in order to create a well-fitting suction socket. And we've just recently been introduced to the transfemoral as well as the through knee potential of this system. And again, if we are able to create that cast in a even, under full compression in an even manner, that's already distributing weight or distributing tissue under weight bearing, as Arthur said, I think that's pretty exciting. I think that should change things a lot for a lot of people.
On a personal level, has using the SAS system for each one of you made you a better practitioner?
No, it was pretty awesome to begin with, so
yeah, me too.
I can't see this.
It's made me more awesome.
You have to use your editing skills on that one. How could you do that? On a personal level, I think, again, as I keep using the same word, going back to consistency, being able to track things, being able to see where mistakes may have occurred, being able to determine whether or not it was the socket design, maybe it's the liner that we've chose, maybe it's the interface material that we've chosen, and the more things that we can isolate and be consistent with, I think we're going to end up being able to really look at those other the other materials, the other factors that are involved, and being able to recreate something scientifically, I think that's a huge advantage.
Yes, as we've talked about this morning, we come back to this word consistency. Mm-hmm. It's consistent, it's repeatable, it's generally more comfortable for the patients. Who doesn't want to have that available to them in their clinical practice?
You know, we have a lot of patients. I always get patients that will come in and ask me about computer design, digital scanners, because to them it's computerized, that's modern, that's got to be better. And we found over the years, and I've been introduced to those systems, I've had the opportunity to try those systems myself. You know, if you're talking about a digital scan, you're looking at a topical picture of a limb in a seated position or in a non-weight bearing position, and that changes so much the way the tissue is manipulated under full weight bearing and compression. I mean, I just think that this is far superior to that type of technology. And so, yeah, we're pretty excited about it.
Cool. How important is the liner choosing process for using the SAS system?
I think that's been one of the big learning curves for us, and we're still figuring out the best liner combination to use with this system. Andreas has his own liner available, and I think having trusted him through this whole process, I'm kind of excited to try that liner with the system. I think a consistent thickness as opposed to a contoured liner makes sense with the vector control system. So yeah, we're pretty excited to try the new liners.
Yeah, I mean, in the past it depends. There are certain practitioners that are very in tune with that, but there are others that are simply taking measurements and finding a liner that fits in appearance. But again, the question comes down to what is happening to the tissue underneath the liner under weight bearing, whether it's the skeleton, whether it's the soft tissue itself. How is that being manipulated inside of the socket? And like I said earlier, once you're able to have something that you can recreate in a consistent method, I could potentially cast somebody, if I wanted to research, I could potentially cast somebody in 3 different types of liner materials, and again, use the Aqua system itself is going to apply as long as I'm following the same guidelines and getting the same amount of pressure under every cast. That socket is going to be the same shape. And then I would be able to potentially fit somebody and determine, that person might say, this socket is far more comfortable than this socket. And it's simply just a liner, the interface material that's been changed. And being able to learn from that is going to benefit practitioners, it's going to benefit the patients that we see. So it's good.